In the history of aviation, there are airplanes that change the rules, and then there are airplanes that seem to defy them entirely. In the late 1950s, one aircraft did something no production jet had ever done before. It flew at twice the speed of sound. It climbed higher, faster, and farther than anything that came before it. And for a brief, shining moment, it convinced the world that absolute speed was the ultimate answer to modern warfare. That aircraft was the Lockheed F-104 Starfighter. To those who first saw it on the runway, the F-104 looked less like an airplane and more like a weapon. Its fuselage was long and impossibly thin, tapering into a needle-sharp nose. Its wings were so small and so razor-thin that ground crews were required to cover their leading edges to avoid serious injury. One Air Force officer famously joked that it looked like a man riding a missile. Lockheed embraced the nickname. The Starfighter was not designed to dance in the sky. It was designed to strike upward like a spear. The mind behind this radical machine belonged to one of the most influential engineers in American history, Clarence Kelly Johnson. By the time the F-104 was conceived, Johnson was already a legend. He had designed the P-38 Lightning during World War II, overseen the development of the F-80 Shooting Star, America's first operational jet fighter, and later would go on to create the U-2 and the SR-71 Blackbird. Johnson ran Lockheed's secretive Skunk Works division with near-absolute authority, demanding simplicity, speed, and discipline above all else. In the early 1950s, Johnson became convinced that modern fighter design had gone in the wrong direction. Aircraft were becoming heavier, more complex, and slower to respond. The skies over Korea seemed to confirm his fears. American pilots flying the F-86 Sabre were encountering Soviet-built MiG-15s that could climb faster and operate at higher altitudes. Even when American pilots prevailed, it was clear that the margin was shrinking. Johnson believed the answer was not another compromise aircraft, but a pure interceptor, a fighter built for one purpose only: to climb faster than anything else, reach extreme altitude, and destroy enemy bombers before they could strike. In 1952, he personally traveled to Korea and spoke directly with combat pilots. When he returned, he sketched an airplane that eliminated everything not essential to speed. That sketch would become the F-104. The Starfighter was built around a single, enormously powerful engine, the General Electric J-79 turbojet. At the time, it was among the most advanced engines ever created, capable of pushing an aircraft beyond Mach 2. Everything else in the design served that engine. The wings were kept extremely small to reduce drag at supersonic speeds. The fuselage was narrow to minimize frontal area. Fuel, landing gear, avionics, all were squeezed into the body like organs packed around a spine. The result was unlike anything the world had seen. On March 4, 1954, the first XF-104 prototype took to the air from Edwards Air Force Base in California. Test pilots immediately realized they were flying something extraordinary and unforgiving. Early flights revealed astonishing acceleration and climb performance, but also demanded absolute precision. This was not a machine that tolerated casual handling. By 1958, the Starfighter entered operational service with the United States Air Force and almost immediately began rewriting the record books. On May 16, 1958, an F-104, piloted by Commander Howard C. Johnson, set a world speed record of 404 miles per hour. Just days later, another Starfighter reached an altitude of over 91,000 feet. Soon after, it became the first aircraft to exceed 100,000 feet after taking off under its own power. No rockets, no assistance, just raw jet thrust. For a time, the F-104 held world records for speed, altitude, and time to climb simultaneously. No other aircraft had ever achieved that trifecta. To the American public, this silver dart symbolized technological dominance at the height of the Cold War. It appeared at air shows, screamed overhead in dramatic flybys, and featured prominently in recruiting materials. Against the backdrop of Sputnik and nuclear anxiety, the Starfighter seemed to promise something reassuring, that American engineering could always stay one step ahead. Yet even in these early triumphs, there were quiet warnings. Test pilots respected the F-104, but few loved it. The aircraft demanded constant attention. Its margins were thin. Small mistakes could escalate quickly. Some pilots remarked that it felt more like balancing on a blade than flying an airplane. Kelly Johnson himself acknowledged that the Starfighter was not for the average pilot. It was built for the elite, men who understood that performance always came at a price. What few could foresee was just how high that price would eventually be. The Starfighter had been created as a masterpiece of specialization, a pure expression of speed and climb in aluminum and steel. In its intended role, a high-altitude, fair-weather interceptor, it was nearly unbeatable. But history has a way of testing machines in ways their designers never imagined. At the moment of its greatest triumph, with records shattered and confidence soaring, the F-104 stood at the peak of its reputation. It was hailed as the future of aerial combat, a symbol of Cold War supremacy, and one of the most advanced fighters ever to enter service. Soon, however, the same qualities that made it magnificent would begin to reveal a darker side, one written not in records and headlines, but in accident reports, funerals, and the quiet grief of those left behind. The legend of the Starfighter had only just begun. As the Starfighter captured headlines and set records, the world it had been designed for was rapidly taking shape. The late 1950s were not simply a time of technological optimism. They were an era defined by fear, urgency, and the ever-present possibility of nuclear war. The F-104 did not emerge from a vacuum. It was a direct product of Cold War reality and the hard lessons learned in the skies over Korea just a few years earlier. When North Korean forces crossed the 38th parallel in June of 1950, jet combat was still in its infancy. The United States entered the conflict flying straight-wing aircraft like the F-80 Shooting Star and propeller-driven fighters left over from World War II. That illusion of technological comfort vanished in November 1950 when Soviet-built MiG-15s appeared over the Yalu River. Sleek, fast, and capable of climbing higher than most American aircraft, the MiG-15 shocked U.S. commanders and forced an immediate reassessment of air combat doctrine. The American response was the F-86 Sabre, a swept-wing jet that would go on to earn a formidable reputation. In the hands of experienced pilots, the Sabre could match the MiG-15 in combat, and American pilots achieved a favorable kill ratio. But the numbers hid an uncomfortable truth. The MiG often dictated the terms of engagement. It could climb faster, disengage at will, and retreat to higher altitudes where American aircraft struggled to follow. Speed and altitude had become the new currency of survival. For U.S. Air Force planners, the lesson was unmistakable. The next war might not be fought over a distant peninsula, but over American cities themselves. The Soviet Union was developing long-range bombers capable of carrying nuclear weapons across the Arctic. Aircraft like the Tu-95 Bear threatened to approach at high altitude and high speed, leaving defenders only minutes to react. The United States did not need another dogfighter. It needed an interceptor that could launch, climb almost vertically, and destroy bombers before they reached their targets. This strategic anxiety found its strongest advocate in Kelly Johnson. Johnson believed that modern fighter aircraft had become burdened by competing requirements: maneuverability, range, payload, and versatility, all of which diluted performance. His answer was radical: abandon versatility entirely. build an aircraft that did one thing better than any other machine in the sky. By 1953, Lockheed engineers were working under intense secrecy on what Johnson called a minimum airplane. Every pound of weight was questioned. Every system had to justify its existence. The wings were reduced to the smallest possible size that could still produce lift at high speed. The fuselage became a slender tube, shaped to minimize drag. Even the pilot sat in a tightly confined cockpit, surrounded by gauges and warning lights that reflected the aircraft's unforgiving nature. This philosophy stood in stark contrast to prevailing trends. Many designers favored delta wings and multi-role platforms that could adapt to changing missions. Johnson rejected this approach outright. He argued that no aircraft could excel at everything, and that trying to do so invited mediocrity. The Starfighter would be a specialist, fast, high-flying, and deadly in a narrow window of combat. The United States Air Force initially shared this vision. Early operational concepts imagined F-104s sitting on alert, ready to scramble at a moment's notice. Once airborne, they would climb faster than any enemy bomber, fire radar-guided missiles, and return to base within minutes. In this role, speed was not just an advantage, it was the aircraft's primary defense. But even as the Starfighter entered service, the strategic landscape was shifting again. Surface-to-air missiles were becoming increasingly effective. Intercontinental ballistic missiles promised to bypass air defenses altogether. The interceptor mission that had given birth to the F-104 was already beginning to lose its central importance. This tension between the aircraft the Starfighter was designed to be and the missions it would eventually be asked to perform lay quietly beneath the surface. For the moment, the aircraft's extraordinary performance masked the problem. Pilots marveled at its acceleration. Commanders pointed proudly to its record-setting capabilities. On paper, the Starfighter appeared to be exactly what the Cold War demanded. Yet the seeds of future tragedy were already planted. An aircraft optimized for one narrow purpose would soon be pushed into roles it was never meant to fulfill. And when that happened, the unforgiving logic of its design would assert itself with brutal clarity. The Starfighter had been born from urgency and ambition, shaped by the fears of the early Cold War. It was a weapon forged for a specific moment in history. What no one fully grasped, not the engineers, not the strategists, and not the pilots, was how little room it left for compromise, and how dangerous that rigidity would become once the world asked it to be something it was never intended to be. The true nature of the Starfighter revealed itself not in record attempts or carefully planned demonstrations, but in the ordinary moments of flight, during takeoff, approach, and landing, when pilots were forced to confront the consequences of its radical design. What made the F-104 extraordinary at Mach 2 also made it one of the most demanding aircraft ever placed into operational service. At the center of the Starfighter's personality were its wings. They were unlike anything seen before or since on a production fighter. Extremely short, perfectly straight, and razor-thin, each wing spanned barely over 7 feet from root to tip. Their thickness-to-chord ratio was so small that they could not house fuel tanks or landing gear. Even structural strength was a challenge. Lockheed engineers famously described them as knife blades, optimized for slicing through the air at supersonic speed. At high altitude and high speed, the wings performed exactly as intended. Drag was minimal. Acceleration was astonishing. But aerodynamics is always a game of trade-offs, and at low speeds those wings became a liability. The F-104 had one of the highest wing loadings of any fighter aircraft of its era. In practical terms, that meant the airplane needed to fly very fast just to stay airborne. Landing the Starfighter was an exercise in precision. Approach speeds routinely exceeded 180 miles per hour, and could climb past 200 miles per hour depending on weight and conditions. For pilots accustomed to slower, more forgiving aircraft, the margin for error felt terrifyingly small. There was no room for sloppy technique, no chance to salvage a bad approach. If speed dropped too low, the aircraft did not mush gently toward the runway. It fell. Compounding the problem was the Starfighter's tail design. To keep the horizontal stabilizer clear of turbulent airflow during supersonic flight, Lockheed mounted it high on top of the vertical fin, creating what is known as a T-tail configuration. At speed, this arrangement worked beautifully. At high angles of attack, however, it introduced one of the aircraft's most dangerous characteristics. When the nose pitched up sharply, airflow over the small wings could blank out the tailplane entirely. The result was a sudden and violent loss of pitch control, a phenomenon known as pitch-up. Once it occurred, recovery was often impossible. The aircraft would enter a deep stall, tumbling uncontrollably despite full control inputs. Pilots described it as if the airplane simply stopped listening. This was not a theoretical flaw discovered years later. Test pilots encountered pitch-up early in the F-104's development, and while procedural limits were established to reduce the risk, the danger remained embedded in the aircraft's aerodynamics. Avoiding it required constant awareness and strict discipline, especially during maneuvering and approach. The Starfighter's handling characteristics earned it a reputation as an aircraft that punished complacency. Experienced pilots respected it deeply, but many acknowledged that it demanded more mental bandwidth than most fighters. The cockpit was crowded with gauges, warning lights, and system indicators, all competing for attention. A pilot falling behind the airplane, even briefly, could find himself in serious trouble. Ironically, some of the systems designed to make the F-104 safer introduced their own vulnerabilities. To compensate for the tiny wings during landing, engineers added a boundary layer control system. This system bled hot, high-pressure air from the engine and blew it over the flaps, increasing lift and reducing stall speed. When it worked, it was remarkably effective. But the system depended entirely on engine performance. Any drop in engine power, whether from throttle mismanagement, mechanical issues, or incipient failure, immediately degraded lift. In those moments, stall speed increased sharply, often faster than a pilot could react. A system intended to save the aircraft could vanish in an instant, leaving no buffer at the most critical phase of flight. Taken together, these characteristics created an airplane that was stable and brilliant in its narrow design envelope, and unforgiving everywhere else. The Starfighter was not inherently unstable, but it was intolerant of deviation. It demanded perfect execution every time. This reality did not make the F-104 unique in a technical sense. Aviation history is filled with high-performance machines that required exceptional skill. What set the Starfighter apart was how often ordinary operations placed pilots right at the edge of its limits. Takeoff and landing, usually routine phases of flight, became moments of heightened risk. Kelly Johnson understood these compromises better than anyone. He famously remarked that the Starfighter was not a forgiving airplane. In his view, it was a precision instrument meant for a specific mission and flown by carefully selected pilots. Used correctly, it was unmatched. Used carelessly, or outside its intended role, it could be deadly. As long as the F-104 remained a high-altitude interceptor, flown in clear weather by elite crews, its risks could be managed. But aircraft rarely remained confined to the roles envisioned by their designers. As the Starfighter spread beyond the United States and into the air forces of America's allies, it would encounter new missions, new environments, and new demands. And under those pressures, the razor-thin margin between brilliance and catastrophe would begin to disappear. If the Starfighter's aerodynamics demanded perfection, its machinery offered little mercy when things went wrong. Beneath the sleek aluminum skin was a web of advanced systems that pushed the limits of 1950s technology, systems that delivered extraordinary performance, but often at a cost of reliability. In the F-104, small mechanical failures had a dangerous habit of becoming fatal emergencies. At the heart of the aircraft was the General Electric J-79 turbojet engine. When it worked properly, it was a marvel. The J-79 gave the Starfighter its breathtaking acceleration and its ability to punch through the sound barrier with ease. Few engines of the era could match its thrust-to-weight ratio. It was the reason the F-104 could climb like a rocket and outrun almost anything in the sky. But early versions of the J-79 were notoriously temperamental. Compressor stalls, sudden disruptions of airflow inside the engine, were an ever-present risk. In some cases, these stalls escalated into full flameouts, where the engine simply shut down. For a twin-engine aircraft, such a failure might be survivable. For the Starfighter, it was often a death sentence. The F-104 had the glide characteristics of what pilots grimly described as a brick. With its tiny wings and high wing loading, it lost altitude rapidly when power was reduced. An engine failure at low altitude left the pilot with only seconds to act, and sometimes no viable options at all. In West Germany, later accident analyses would show that engine-related issues played a role in a significant percentage of crashes. As dangerous as engine failure was, the means of escape proved even more lethal. Because of the high-mounted T-tail, Lockheed engineers feared that a conventional upward-firing ejection seat might send a pilot directly into the tailplane at high speed. Their solution was the Stanley C-1 ejection seat, a radical design that fired the pilot downward through the bottom of the aircraft. On paper, the idea made sense. At high altitude and high speed, a downward ejection avoided the tail and allowed for safe separation. In reality, most emergencies did not occur at 40,000 feet. They occurred during takeoff, climb out, approach, or landing, exactly when altitude was scarce. For pilots in trouble close to the ground, the downward firing seat offered no salvation. Below a certain altitude, ejection meant immediate impact with the Earth before the parachute could deploy. Numerous pilots died, not because they delayed ejection, but because they ejected exactly as trained and had no chance to survive. One of the most tragic examples occurred on July 26, 1958, when Lieutenant Colonel Ivan Kincheloe Jr., a celebrated Korean War ace and one of America's most respected test pilots, suffered an in-flight emergency in his F-104. Attempting to escape at low altitude, Kincheloe ejected. The seat fired him downward, and he was killed instantly. His death sent shockwaves through the aviation community. If a pilot of his experience could not survive an emergency in the Starfighter, what hope did others have? Later variants of the F-104 would be retrofitted with conventional upward-firing seats, saving many lives. But for hundreds of early pilots, the original design remained a fatal trap. Even systems intended to enhance safety carried hidden dangers. To make landings possible with such small wings, the Starfighter relied on a boundary layer control system that diverted hot air from the engine and blew it over the flaps. This increased lift and reduced landing speed, but only as long as the engine was producing sufficient power. Any reduction in engine RPM immediately weakened the system. In a flameout or throttle malfunction, lift could disappear almost instantaneously. Stall speed increased dramatically, often faster than a pilot could compensate. In those moments, the aircraft transitioned from marginally controllable to unrecoverable in seconds. What made the situation especially perilous was how tightly interconnected the Starfighter's systems were. An engine hiccup could degrade lift, compromise controllability, and force an ejection system that might not work at the available altitude. Each link in the chain amplified the next. Pilots described emergencies in the F-104 as brutally fast. There was no time for troubleshooting or second chances. Decisions had to be made immediately, under extreme stress, often at low altitude and high speed. Even a correct decision could end in disaster. None of this meant the Starfighter was poorly engineered. On the contrary, it was a triumph of pushing technology to its limits. But those limits left no margin. The aircraft demanded perfect systems and perfect execution simultaneously, a standard that real-world operations could rarely guarantee. As the Starfighter spread beyond the United States into Allied air forces, these vulnerabilities would be exposed repeatedly. And nowhere would the consequences be more severe than in the country that adopted the F-104 in greater numbers than any other. The stage was set for the darkest chapter in the Starfighter's story, one that would transform a record-breaking interceptor into a national tragedy. Nowhere did the Starfighter's unforgiving nature collide more violently with reality than in West Germany. What began as a symbol of rebirth and technological progress for a newly reformed nation would become one of the most painful aviation crises in modern military history. In the late 1950s, the Federal Republic of Germany was rebuilding its armed forces under the umbrella of NATO. The Cold War front line ran straight through Central Europe, and West Germany was expected to play a critical role in stopping any potential Soviet advance. When the time came to choose a modern combat aircraft, the Lockheed F-104 appeared to offer exactly what was needed: speed, prestige, and a clear connection to American technological leadership. In 1958, West Germany committed to purchasing the Starfighter in unprecedented numbers. In total, the Luftwaffe and German Navy would acquire 9 U-16 aircraft, making Germany the largest operator of the F-104 anywhere in the world. The decision was controversial even at the time, but political, strategic, and industrial considerations pushed it forward. German industry would license produce major components, and the aircraft would symbolize Germany's return as a modern air power. What followed was catastrophic. Between 1961 and 1989, 292 German Starfighters were lost in accidents. 116 pilots were killed. At the height of the crisis in the mid-1960s, a German F-104 was crashing, on average, once every 2 weeks. Newspapers ran grim tallies. Public confidence collapsed. The aircraft earned its most infamous nickname, Der Witwenmacher, the Widowmaker. To understand why the losses were so severe, one must look beyond the aircraft itself. The tragedy was not caused by a single flaw, but by a convergence of design, doctrine, environment, and human factors, a perfect storm. The F-104 had been designed as a high-altitude, clear-weather interceptor. NATO, however, needed something very different. Faced with the overwhelming numerical strength of Warsaw Pact ground forces, alliance strategy emphasized low-level strike missions to destroy enemy formations, airfields, and supply lines. German starfighters were expected to fly fast and low, often just a few hundred feet above the ground, carrying bombs and external fuel tanks in all weather conditions. This was the exact opposite of the mission the Starfighter had been built for. To adapt the aircraft, Germany adopted the F-104G variant, heavier, reinforced, and packed with complex avionics for navigation and attack in poor visibility. These modifications further reduced performance margins and increased mechanical complexity. The aircraft was now routinely flown, overloaded, at high speed, in turbulent air, through rain, fog, and icing conditions common to Central Europe. The environment alone was unforgiving. Unlike the wide-open skies of the American Southwest, German pilots operated from shorter runways, surrounded by hills, forests, and dense civilian infrastructure. Low-level flight left no room for recovery from disorientation, mechanical failure, or momentary error. In such conditions, the Starfighter's razor-thin safety margins became lethal. Pilot training compounded the problem. Many Luftwaffe pilots transitioned to the F-104 from much slower, more forgiving aircraft. Although they received instruction in the United States, much of that training took place in the clear skies of Arizona and California, conditions that bore little resemblance to Northern Europe. Two-seat trainer versions of the F-104 were in short supply, forcing pilots to solo the aircraft sooner than ideal. Maintenance crews were under similar pressure. The F-104G was a demanding machine that required meticulous upkeep. Germany struggled with shortages of spare parts, experienced technicians, and standardized procedures during the rapid expansion of its air force. Small maintenance errors could, and often did, have fatal consequences. The human toll was devastating. Funerals became routine. Entire squadrons lost multiple pilots in a single year. In one infamous incident in June 1962, 4 starfighters practicing for an air show crashed in formation, killing all 4 pilots. Investigations revealed no single cause, only a chain of factors that spiraled beyond control. Germany was not alone. Canada, which also used the Starfighter in a low-level strike role, suffered even higher proportional losses. Of 238 Canadian F-104s, 110 were destroyed in accidents, nearly 46% of the fleet, with 37 pilots killed. Other operators experienced fewer losses, but the pattern remained consistent. The farther the Starfighter was pushed from its original mission, the deadlier it became. Over time, improvements helped. Upward-firing ejection seats saved lives. Better training reduced some risks. Accident rates declined in later years. But the damage to the Starfighter's reputation was irreversible. For an entire generation of pilots and families, the F-104 would always be remembered not for its records, but for its funerals. So why did the F-104 Starfighter kill so many pilots? The answer is not simple, and that is precisely the lesson. The Starfighter was not a bad aircraft. In its intended role, flown by well-prepared crews under the right conditions, it could be remarkably effective. But it was a machine built with almost no tolerance for deviation. Its design flaws were manageable only within a narrow envelope. Outside that envelope, they became deadly. What made the tragedy inevitable was the combination of factors. An aircraft optimized for speed was forced into low-level attack missions. A complex high-performance jet was introduced into rapidly expanding air forces still finding their footing. Technical weaknesses intersected with environmental hazards and human limitations. Each accident was not a failure of a single person or component, but a link in a chain. The legacy of the Starfighter is therefore not one of simple condemnation, but of caution. It stands as a reminder that technological ambition must be matched with operational reality. That brilliance in design does not excuse rigidity in doctrine. And that when humans are placed inside machines built at the edge of possibility, the margin between triumph and tragedy can be frighteningly small. The F-104 reached for the sky faster and higher than any aircraft before it. It embodied an era that believed speed could solve everything. But for hundreds of pilots, especially those in Germany and Canada, it became a lesson written in loss, a flawed masterpiece, a monument to ambition, and one of the most sobering chapters in aviation history.